Hi, my name is Franklin Nolly Williams. I have a Bachelor of Science degree from Southern Illinois University in occupational education, but my greatest claim to fame is that I published a paper with the online journal, the Journal of Cosmology, volume 24, article 49, entitled A Mathematical Way to Derive the Universal Constants, relating them to the fine structure constant alpha as a continuous equation involving pi and the square root of 10. This is the equation right here. This is alpha. This is the square root of 10. Beta is the square root of 10. And pi is its standard usual self. These three, the only numerology, in fact, taking place was making alpha here equal alpha on this side of the equation. And these three non-dimensional, irrational numbers taken to some exponential value can derive all of the universal constants of the CODATA bulletin or the standard accepted values accepted by NIST. That's NIST, NIST. But that's not the point of this video. I saw in a YouTube video where Dr. Hassenfelder stated that we may need a new physics to explain the difference between quantum mechanics and gravity. I think not. We just need to reanalyze our old physics and find out where we went wrong. In this series I'm about to present to you, I call it the KISS principle, Keep It Simple Science. It comes from a paper I wrote entitled The Principle of Reality versus the Principles of Relativity, the Universe Without the Necessity of an Observer, published in Academia EDU. In this presentation, we will demonstrate that the Hamiltonian is in fact the unified field equation. Sir William Rowan Hamilton was an outstanding Irish physicist, published a paper in 1834 which stated that the total potential energy of a system added to the total kinetic energy of that system would equal the total energy of the whole system. That's this equation right here. Now these are variations of the equation for relativity, but they're all the same exact equation. The n here represents v divided by c. Now if we consider the universe as a slowly rotating, expanding, loosely packed system in and of itself, made up of billions and billions of smaller systems, such as galaxies, stars, solar systems, and planets, dust and debris, then the unified field equation has been known by almost all physicists, and certainly every theoretical physicist since 1834. I have read the theories of relativity of Einstein. While I understood most of the math, it is the logic that confuses me, because it is from a third-person point of view, as if we are not participants in our universe. Because of Einstein's theories, we have been told all my life that no mass can exceed the speed of light, and yet nowhere in Einstein's theories does it preclude neutral mass from exceeding the speed of light. We have been told that it will take infinite energy to reach the speed of light, and if we exceed the speed of light, we will go into the past in time. Neither of which is true. Both scenarios will be discussed in this presentation. I will read an excerpt from Einstein's 1905 paper, The Special Theory of Relativity, or more precisely on the electrodynamics of moving bodies, which more truly should have been called on the electrodynamics of moving charged bodies. The word electrodynamics should have been the first clue. He uses an electromagnetic field to accelerate an electron and the electric charge, no matter how small, to make a ponderable mass, a giant electron. Now this excerpt comes from the section in Einstein's theory called Dynamics of the Slowly Accelerated Electron. We remark that these results as to the mass are also valid for ponderable material points because a ponderable material point can be made into an electron, in our sense of the word, by the addition of an electric charge, no matter how small. As the electron is to be slowly accelerated and consequently may not give off any energy in the form of radiation, the energy withdrawn from the electrostatic field must be put down as equal to the energy of motion W of the electron. And from that he develops the equation E equals mc squared. The expression for the kinetic energy must also, by virtue of the agreement stated above, apply to ponderable masses as well. Now it's interestingly, Einstein makes a similar comparison in his 1911 paper on the influence of gravitation on the propagation of light, where he uses gravitation to accelerate a mass, adding inertial energy to the mass with no charged bodies included. I'll read that excerpt. The meaning of this result is shown particularly clearly if we consider the following cycle of operations. The energy E, as measured in S2 sub 2, is emitted to the form of radiation in S2 towards S sub 1, where by the result just obtained, the energy E of 1 plus gamma h divided by c squared, as measured in S1, is absorbed. A body W of mass m is lowered from S2 to S1, work m gamma h being done in the process. The energy E is transferred from S sub 1 to the body W while W is in S sub 1, letting the gravitational mass m be thereby changed so that it acquired the value m prime. Let W be again raised to S2, work m prime gamma h being done in the process. The energy, let E be transferred from W back to S2. The effect of this cycle is simply that S sub 1 has undergone the increase of energy gamma h divided by c squared, and that the quantity of energy m prime gamma h minus m gamma h has been conveyed to the system in the form of mechanical work. Now here he has added inertial energy to a mass using the gravitational field and not the electric field. Now in 1905, when he published his special theory, he published another paper entitled, Does the Inertia of a Body Depend on its Energy Content? Inertia is simply a body's measure of resistance, usually in the form of mass, to change from a state of equilibrium where all forces acting upon it added together result in zero. One could restate Newton's original law of motion to be completely and wholly accurate as a statement of inertial equilibrium. Every body perseveres in its state of inertial equilibrium, which is of rest or uniform motion in a right line with respect to the observer, unless it is compelled to change from that state by unequal and opposing forces impressed thereon. The forces must be unequal because of the second law and opposing because of the third law. It is required that the resultant forces acting upon a body in a state of inertial equilibrium, which is rest or linear translation, be equal to zero. In this paper, Einstein compares bodies to systems with one another. The body itself must constitute a third system. System B is in uniform motion with System A, and the body, the third system, C, is to be at rest in System A. System C's energy is compared to both of these systems, System A and System B, which is in motion with System A. Here's the problem with the scenario. If there is no observer, System C cannot determine whether it is at rest with System A without the comparative measure of an observer, in this case Einstein, who set the scenario. It can only determine that System B is in motion with it if it receives a signal from System B. System B has the same dilemma as System C. Without the comparative measure, such as an observer, it cannot determine that it is in motion with System C if it receives a signal from System C. System A acts only as conveyance of information between System B and System C. If System A is an arbitrary space that contains both Systems B and C, then it also contains an equidistant point that exists between both systems. No matter the relative motions between System B and C, it will always remain equidistant and will recede or close with equal speed between both systems. If mass, it makes no difference whether System B is in motion with System C or System C is in motion with System B. Both systems are in motion with each other. The equidistant point will remain consistent. When you change the equations to fit the scenario, it reduces to the unified field equation that Hamilton provided us, or more precisely, this equation right here or this equation right here. Now this equation here, or this one here, represents the total energy of systems A, B, and C. One of the major constraints of Einstein's relativity is the temporal dimension. According to the relativity theory, traveling faster than light allows you to go into the past. Therefore, most physicists will not even consider the idea of traveling faster than light because they cannot explain this phenomenon. The time coordinate can move forwards or backwards mathematically without constraint. If you really travel back into the past 50 years, when you look up the night, and you're standing on the face of the earth and you look up the night sky, what you have to see is the same constellations the way they were 50 years ago. You do not just send yourself back in the past, you also reverse 50 years of entropy of the universe. That takes a lot of power and energy, and I know no one that can violate the second law of thermodynamics, except maybe God himself. We see it as impossible from a logical point of view to travel to the past, but the theories of relativity allow this very thing. This cannot happen not because relativity is wrong, because it's not, but because there are two temporal dimensions. The biggest surprise is that we are subject to them both every day without ever knowing it or being disoriented. Nature compensates well. Sometimes we are disoriented. It's called motion sickness. I must confess, I was not the first to consider this. Two great physicists of the past, Arthur Milne and P.A.M. Dirac, were the first enlightened physicists to think of this. However, their efforts fell short trying to preserve relativity in its current form. They considered one temporal dimension to be the exponent of the other, and experiments failed to prove this out. It does not mean that they were wrong. The temporal dimensions are there. They are simply added together along with the three other dimensions in the coordinate system, giving us 5 dimensions. Physicists little understand or comprehend the dimension of time. Newton saw time as absolute, unaffected, forever marching forward. Absolute, true, and mathematical time of itself and from its own nature flows equally without relation to anything external. Einstein, on the other hand, saw time as a vector with magnitude and direction from point A to point B, affected by a traveler's relative velocity from A to B. Again, I'll read an excerpt from Einstein's own theory on the electrodynamics of moving bodies. He says, from this there ensues the following peculiar consequence. If at the points A and B of K there are stationary clocks which viewed in the stationary system are synchronous, and if the clock at A is moved with the velocity v along the line AB to B, then on the arrival at B the two clocks no longer synchronize, but the clock removed from A to B lags behind the other which has remained at B by 1/2 t times v squared divided by c squared, up to the magnitude of fourth and higher order. T being the time occupied by the journey from A to B. If we assume that the result proved for a polygonal line is also valid for a continuous line, we arrive at the result that 1/2 t times v squared divided c squared seconds slower if it moves around in a circle. If one of the two synchronous clocks is moved in a closed circle with constant velocity until it returns to A, the journey are lasting t seconds, then by the clock which has remained at rest, the travel clock on the arrival at A will be 1/2 t v squared divided c squared seconds slow. This is true because what you realize is that A has to be accelerated. You're adding energy to it. Even if it moves in a circle, it's still being accelerated. You're adding energy to A. So it's actually, you'd say, the square root of acceleration times the distance, because that gives you the velocity. But the thing is, it requires to be accelerated. Of course, this being true, then it means that our universe is 5-dimensional, just as Theodore Kaluza suggested in 1920. The only difference is that Theodore Kaluza never thought of the extra dimension as a temporal dimension. But a force is represented by a field and can be related to a linear dimension so that we have 5 dimensions. This unites all the forces of nature. Physicists really do not know how or why time exists, but they do know how to measure it very precisely, or at least they think they do. The truth is they do not understand the one dimension of time and can hardly conceive the idea of two. To travel into the past, one must reverse and retrace all these dimensions exactly without deviation. The unique thing about the temporal dimension is that it shows that no matter how many times faster than the speed of light one goes, one cannot travel into the past. Time simply slows infinitely, with the universe collapsing behind critical radius after critical radius while the observer moves through it. And this is the equation here for time, where n is again v divided by c. And because 2km divided by c squared is equal to the Schwarzschild's radius, and if we let v equal the speed of light c, then our equation becomes that very equation right there, which demonstrates that time slows infinitely but never reverses itself. Now, you may not believe any of this stuff I've just said or presented in my presentation here, But that's not really relevant. But what I'd like to mention is that the reality is that physicists need to reanalyze their logic and start using math to describe reality rather than trying to fit reality into their math. Thank you for watching.